today we are going to discuss another very interesting topic of a numerical method, central difference and difference table. Then later on we discuss about Gauss forward central interpolation formula and Gauss backward central interpolation formula. So let us discuss about central difference operator, then central difference formula. So what is the notation of a central difference operator? We denote the central difference operator by the delta. So what is the notation? If we write a notation here, notation is a what? Notation is a delta. This is the notation for the central difference operator. Now how we define the central difference operator? So in order to define the central difference operator, here we write a definition, and how we define the central difference operator in term of any function. So delta of fx equal f of x plus h by 2 minus f of x minus h by 2, x minus h by 2, where h is a class interval, means the difference between second data to first data, third data to second data onwards. So if we have a data in term of x and fx, for example, suppose we have a data x with a x0, x1, and we may also write, because here we are going to define the central difference operator and central difference table for the equal class interval. So we may also write x1 equal what? x1 equal x0 plus h. So x0, x1, similarly here x2 we may also write x1 plus h or x0 plus 2h, This one is a what? This one is a x2. In a similar manner, for sake of a simplicity, suppose here we consider only a 3 data x3, not a 3 data, means here 4 data x0, x1, x2, x3, and x3 may also write in term of x2, this one is a x2 plus h, and in term of x0, this one is a x0 plus 3h, So here if we write f of x, so this one is a f of x0, this one is a f of x1, you may also write this one is a what? This one is a f of x0 plus h also, because what is the value of x1? The value of x1 is x0 plus h. Similarly, f of x2 equal f of x0 plus 2h, and f of x3, here we write f of x3, and you may also write in term of x0 and h, this one is the value of x0 plus 3h, Now how we define for this function, means how we define the central difference for the f of x0. So to define, in order to define the central difference of f of x0, so here we write in place of x what? Here we write in place of x, we write x0. So del of f of x0, this one equal, in place of x, just we put the value of x equal x0. So this become f of x0 plus h by 2 minus f of x0 minus h by 2, x0 plus h by 2 and x0 minus h by 2. So here there is no any function, means a function is not defined at a point x0 plus h by 2 and x0 minus h by 2. Then how we define the central difference? First order central difference. So in order to define the first order central difference, of f of x0, just we replace x0 by the x0 plus h by 2. Means here we write, in place of x0 we write x0 plus h by 2, x0 plus h by 2. So what will happen on the right hand side? If we put in place of x0, in place of x0, x0 plus h by 2, then in the right hand side this become f of x0 plus h by 2 plus h by 2 minus f of x0 minus h plus h by 2 minus h by 2. Here just say that in place of x0 we write what? We write x0 plus h by 2, then this become what? Then this become f of x0 plus h by 2, h by 2, x0 plus h by 2 and h by 2. So what will happen? Just we perform this one in the next page. So what will happen here? Just we write in place of once again here we write f of x0 delta of f of x0 equal f of x0 plus h by 2 minus f of x0, so x0 minus h by 2. So this one is so if we put delta in place of x0, as we say that in place of x0 just we write x0 plus h by 2. So this become f of x0 plus h by 2, this become f of x0 plus h by 2 and plus h by 2, this become h minus f of x0 plus h by 2 minus h by 2, then after simplification this become f of x0 plus h minus f of x0. So this one is and if we write in term of a y, means y equal y0 with the f of x0, y1 with the f of x0 plus h, y2 with the f of x0 plus 2h. So you may also write this one in term of a what? Del y what? This one is a y1 by 2, y1 by 2 equal y1 minus y0. If what? If y0 equal what? y0 equal f of x0 and y1 equal f of x0 plus h. And in a similar manner, how we define? y1 by 2 equal what? F of x0 plus h by 2. This one is what? This one is a first order central difference. In a similar manner, you may also define the second order central difference. So how we define the second order central difference? Before defining the second order central difference, just we write some more terms in term of a what? In term of a difference table, means how we construct a difference table for a given data. So here just we are going to define a central difference table. So what will happen here? Just we define our central difference table. So how we define a central difference table? So in order to properly form a central difference table, first we write data in terms of x and fx. Once we write the data in x and fx, then we define the central difference table. So here we write a x, here we write a x, this one is a what? This one is a x, this one is a x and this one is a f of x. You may also write y equal fx, y equal fx, y equal fx. So here we write a x0 and corresponding the value of a y with a y0, or you may also write in term of x0, this one is f of x0. and here we write a x1, here we write a y1, and you may also write f of x1, or you may also write f of x0 plus h, because central difference forward, backward, as we know that forward, backward and central difference is defined for the equal class interval. So, corresponding to the x2, the value of a function with the y2 equal f of x2, and x3, here we define a y3, this one equal f of x3, and one another term x4, and here we write a y4 equal f of x4, and if here we denote the what? Here we denote the delta of a y. Delta of a y means a first order central difference. So, how we define the first order central difference? So, here we define a delta y1 by 2 equal what? y1 minus y0. Always we write a difference between two values. So, here we write a first central difference del y1 by 2 equal what? y1 minus y0. Similarly, delta y3 y2 equal y2 minus y0. Sorry, not y0, y2 minus y1, and delta y5 by 2 equal y3 minus y2, and delta y7 by 2 equal y4 minus y3. So, this one is what? This one is a first order central difference. This one is a first order central difference. If we denote this one is a first order central difference. Similarly, if we try to define the second order central difference, this one is a notation for this one is a del 2y. This one is a second order for central difference. So, here how we find the second order central difference? So, as we define earlier, here what? Here we define y1 by 2 means this one, delta f of x0 plus h by 2 equal f of x0 plus h minus f of x0, but original definition is this one. This one is the original definition. And if we try to define the second order delta 2 f of x0 equal delta first order central difference of a what? F of x0 plus h by 2 minus first order central difference of a f of x0 minus h by 2. But here what will happen? If we closely look the difference table, here what is this one? This one is a what? This one equal delta f of x0 plus h by 2. And this one equal delta f of x0 plus 3 by 2 h. Means we doesn't have a value for f of x0 plus h by 2 and x0 minus h by 2. Then how we define? So, in order to define here, just we write what? In place of a here we write in place of a what? Here there is a need of a value for what? f of x0 plus h by 2, and here you be right, this one is f of x0 plus this one x0 plus h by 2 and x0 minus h by 2. So, how we define? Just here we write like this one, del f of x0 plus h equal f of x0 plus h minus f of x0, in order to define delta what? In place of if we write in place of what? In place of x0 plus h by 2, there is a need to value of x0 plus h by 2, and in place of difference of these two, x0 plus h by 2 and x0 plus 3 by 2h. So, in order to write this one x0 plus 3h by 2, just we write in place of this one delta f of plus h. In place of just we write in place of x0 we write x0 plus h. Then what will happen here? This become delta f of x0 plus h by 2, and here this become minus delta f of x0 plus h minus h by 2, Then what will happen? Then this become what? This become delta f of x0 plus 3h by 2 minus delta f of x0 plus h by 2. That is required. So, here if we closely observe, this one is a x0 plus 3 by 2h and x0 plus h by 2. The difference of these two with the delta what? Delta f of x0 plus h, and you may also write this one equal what? Delta, in term of a y, this one is a what? Delta y1. This one is a what? Delta y1. So, here just in a one page if we try to define the difference table. So, difference of these two with the what? Second order central difference, and notation of a second order central difference is a what? Delta 2 y1, delta 2 y1. Similarly, difference of these one, delta 2 y1 equal what? We may write delta y 3 by 2 minus delta y1 by 2. Similarly, difference of these two with the delta 2 y2 and difference of this with the delta 2 y3. In a similar manner, we define a third order central difference, fourth order central difference, and nth order central difference. So, now if we closely observe the difference table, this one is a y1 minus y0, this one is a y2 minus y1, this one is a y3 minus y2, this one is a y4 minus y3. When we construct the forward difference table, the always we find a what? Y1 minus y0 means the way of a construction of a central difference table is similar to the way how we construct the forward difference table in a previous lectures. Okay. So, there is a only difference in term of a notation, as we earlier say that the values of a difference table remains unchanged, but the notation in term of a forward, backward and central difference will be different. Okay. So, here this one is a what? This one is a in term of a what? If we try to write in term of a forward difference operator, this one is a what? This one is a del y0. This one is a what? Del y0. And this one is a what? This one is a del y1. So, this one is a what? This one is a del y2, and this one is a what? This one is a del y3. This one is a del y 3. So, you may also say this one is a relation between forward difference and central difference. This one is a relation between forward difference and central difference, means a del y0 equal delta y1 by 2. So, now we try to establish the relation between forward difference and shift operator and forward difference and central difference operator, because in a further means in a next lecture we are going to write a central difference formulae not in term of a central difference operator. We are going to derive the central difference formulae in term of a forward difference operator, because forward difference operator is means we start from the forward difference operator. So, most of the student aware about a forward difference. So, and we already derived the forward interpolation formula. So, we extend the forward interpolation formula for the central interpolation formula also. So, we may write the central difference in term of a what? Forward difference. So, how we write a central difference operator in term of a forward difference operator? So,